In the Lesson 4.2 example, Is it easy to pass the AP exam? We're going to look at the addition rule for mutually exclusive events. Now this rule only applies to mutually exclusive events. What we want to do in this problem is randomly select a student who took the 2015 AP Statistics exam and record the score. The probability model, according to the College Board, looks like this. This means about 23.6% of the students who took the exam scored a 1, which is the lowest score, and about 13.5% of the students scored the highest score, which is a 5. Many people consider scores of 3, 4, or 5 to be passing scores. Many colleges award credit or placement to students who earn these scores. Very few, if any, colleges award credit or placement for scores of 1 or 2. In this question, we want to find the probability that a student that we select scored less than a 3. That means did not earn a passing score. So the probability that a student earned less than 3 means the same thing as the probability that they scored a 1 or a 2. Now, 1s, 2s, 3s, 4s, and 5s are mutually exclusive events. That means that a student who scored a 1, for instance, could not possibly have scored any other score. And so in this scenario, we can use the addition rule for mutually exclusive events to say that the probability that a student scored a 1 or 2 is equal to the sum of the probability that they scored a 1 and the probability that they scored a 2. In this problem, we're going to take those two probabilities from 1 and 2 and add them together to get 0.422. In part B of the problem, we want to find the probability that the chosen student earned a passing score. Now, we may remember that scores of 3, 4, and 5 were considered passing scores. In this problem, we're going to use the complement rule and say that the probability that a student scored a 3 or higher is 1 minus the probability that they scored something under 3. We just calculated the probability that a student scored something under 3 in part A. That was 0.422. And so we're going to calculate it as 1 minus that number, or 0.578. If you'd like to try a problem like this in your textbook, you can try exercise 9 in this section.